This is our last lesson on analytical geometry. From next week, we're going to be starting calculus. So we're going back to paper 1. Some of you, unfortunately, won't be with us anymore, but we're really going to miss you. So let's get started. All right. So we have been speaking a lot about finding tangents to circles. And in the last lesson when Coco was here, that is what she focused on with you, all right, was the sort of introduction to tangents and circles. Unfortunately for us, this section gets a little bit more difficult. So what I wanted to do this evening was do some difficult, well, I say difficult, they're not that difficult, but they are challenging. Do some more sort of challenging sorts of questions with you guys in the hope that you'll be ready for those exams. All right. What I'm going to do is I'm going to show you how we would find the equation of a tangent to a circle when they give us the equation in center radius form, and then they give us the point of tangency. I'm going to give you an opportunity to try that, and then we're going to go and have a look at some sort of slightly more difficult questions, etc., etc. So application of what you were doing with Coco. So let's jump into the first one. They have given us the circle. So we're going to be looking at B, question B, and you guys are going to choose when you do eventually get an option, either you're going to do C or you're going to do D. All right, so they've given us the equation of a circle. They've told us that it's x minus 2 squared plus y plus 3 squared is equal to 17. And they've told us that the coordinates at the point of tangency, I'm just going to call that T, is 1 and 1. All right, what they want us to do is determine the equation of the tangent to that circle. So when they ask us to determine the equation of a tangent, they mean in the form y equals mx plus c. And hopefully we all know by now that means that we need to know the gradient of the tangent, and we also need to calculate its y-intercept. And there's a very specific way in which we do all of this. We always calculate the gradient first, and then we use the coordinates at the point to sub into y equals mx plus c in order to solve for c. All right, so first things first, how are we going to get the gradient? So it's something that we spoke about last time. Okay, well, Coco spoke to you about last time. Remember, if you have got the coordinates of, if you've got the equation of the circle, you have got the coordinates at the center of the circle. So this particular circle has its coordinates at the center, 2 and -3. All right, so now I know it's difficult because we don't have a picture in front of us, but I want you to think about this, okay? You've got a circle, and the coordinates at the center are 2 and -3. There is a point on the circle, okay, which is 1 and 1. Now, I might not be drawing this correctly because it could be the other way as well, but what we've essentially got is that, and our tangent would be somewhere over here, right? How can we use information that we've been given in order to work out the gradient of the tangent? How would we do that? Does anybody have any idea? So it's a bit of a application from last week or Tuesday. Anyone got any ideas? Very, very important concept for us in grade 12. Any ideas, anybody?
We can answer this, guys. Let's look through our notes. We did this.
Go back and have a look.
Yeah,
Teddy, go for it. Awesome, Teddy. How would you do this, do you think? Even if it's wrong, it doesn't matter.
Hello, ma'am.
Hello.
So first of all, we need to find the gradient, right? And that we do by finding the gradient of the line of C to the line to the tangent. We find that gradient. And then obviously the tangent and radius theorem states that it will always be perpendicular, and So the gradient of C to T is times the gradient of the tangent must be equals to -1. So if we find the gradient of C, of the line CT, then we can automatically find the gradient of the tangent.
Beautiful.
And then after that, we sub the points in that we have, and we'll find C.
Lovely. That is fantastic. I could not have explained it any better. Teddy, that was perfect. Okay, so just to run through that for everybody one more time, what Teddy is saying is this, okay? You know that your radius and your tangent are always going to be perpendicular to one another. So if you have got the coordinates at the center and the coordinates at the point of tangency, you can work out the gradient of the radius. So the gradient, or the radius in this case is CT or TC. Right. Then once you've got the gradient of TC, you are going to say that the gradient of TC, the radius, multiplied by the gradient of the tangent gives you -1. Okay, because your radius is always perpendicular to your tangent. Okay, and that will give us the gradient of the tangent, and then we can go and sub that into M, sub in our point at the point of tangency, and work out the value of C. Well done, Teddy, that was perfect. Okay, so subbing into gradient formula, we would end up with 1 plus 3 at the top. So those are our y's. At the bottom, we'd end up with 1 minus 2. So that gives us a 4 at the top and a -1 at the bottom. So that gives us the gradient of TC equal to -4. Now, as I had said to you, my diagram might not be 100% correct, so probably not a good idea for us to look at that. What's important is the algebra that we are doing over here. Okay, so we've worked out the gradient of TC to be -4. So -4 times the gradient of the tangent will give us -1. So that means that the gradient of the tangent is going to be 1/4, like so. Okay, and once we've got that, we can sub into y equals mx plus c. So we're going to put in our gradient first of all, which is 1/4. And now we need to sub in the coordinates at the point of tangency. That is 1 and 1. Sorry, I feel like I'm going to sneeze. Oh, excuse me. Sorry, everybody. So 1 is equal to 1/4 times 1, thank you, plus c. So that means that c is going to be equal to 1 minus 1/4, which is going to give us 3/4. So that means our equation, it is the line y equals 1/4x plus 3/4, like so. Okay. Nontlantha says the gradient of TC is positive. Okay, let's just double check that. Ntlantla, I had drawn a picture here. Remember I said I don't know if my picture's correct. I just drew something. All right, just to talk about it. It's not necessarily accurate. Okay. So let's just double check that we are correct here, but I think we are. All right, we said that the coordinates at the center would be 2 and 3, so that's correct. There's TC, so there's our y minus that y, so 1 plus 3 at the top is there. That's our x minus 2, that's correct over there. That's, no, that is correct. Okay, so I don't think we've made any mistakes here. All right, Ntlantla, because obviously your circle can be like that, and then your tangent could be over there. All right. So not, or yeah, I suppose your tangent could actually be anywhere on the circle. All right, so yeah, don't forget to take screenshots. Okay, thank you, Sebastian. Okay, so let's just practice this idea a little bit before we move on and talk about the next question. Palesa, ma'am, can you please explain from MTC? I don't understand. Okay, so the gradient of your radius. So this is your radius, the gradient of your radius times the gradient of your tangent always gives you -1. Okay, they're always two perpendicular lines. Okay, so if you call that a letter, like if I said that the gradient of the tangent was y, you're essentially saying -4y equals -1, and you're solving for the gradient of the tangent if we called it y. So that's what y, it would be a quarter. Okay, and then you've got to sub that into y equals mx plus c. There's your gradient over there. So this gradient over here is over there. You've subbed in the coordinates at the point of tangency. There they are, there and there. And then you've worked out what your C value is. Okay. All right, let's you guys try one. Okay, so you're just going to do one. Either you're going to do C or you're going to do D. Okay, D is a little bit more difficult. Let's see how that goes. If you've got any questions, please will you ask either Yolanda or I. Yes, Lucinda. Everybody else keep working.
Hi,
You're welcome
ma'am.
to unmute. Hi, Lucinda. How are you?
I'm good, and you, ma'am?
I'm fine, thank you.
Ma'am, we're calculating the gradient of TS, right?
Okay, so you are calculating the equation of the tangent.
No, I mean, oh, you're calculating the midpoint of TS. I want to
No,
understand why.
no, not the midpoint, not the midpoint, not the midpoint. Okay, so when you have a circle,
Yes, ma'am.
okay, and there is a tangent to that circle, okay, there at the point of tangency, they have given you the coordinates, all right? You then have the center of the circle over here. So the line from the center to the point of tangency, that is your radius. This over here is your tangent. The radius is always perpendicular to the tangent.
Yes.
Okay, so that means that the gradient of the radius times by the gradient of the tangent equals -1.
Yes.
So if you know the gradient of the radius, you can use this to calculate the gradient of the tangent.
Okay, ma'am. I understand that.
Okay.
Ne?
Mm-hmm.
We were calculating the gradient for TS, right?
For TC, yes.
Yes,
Yes.
TC. I want to understand why did ma'am say 1 plus 2, not 1 minus 3? Because there, the y
Because it's
coordinate.
1, but it's 1 minus -3.
Oh, okay. Thank you, ma'am.
Okay, all right.
Yeah, thank you.
No problem. 1 minus -3. Okay.
We can do this, guys. On my side, it's even raining. I'm like, yes, let's do this. Feeling the fresh breeze after a hot day.
Lovely. I wish it was raining here. It's your choice whether you want to do C or D. If this is difficult for you, try C. If this is easier for you, then you can try question D. Question D has an extra step. No problem, Palesa. Okay, so Zintle, what we're busy practicing is just finding the equation of a tangent to a circle. So I had done B as an example, and then I was getting everybody to either do question C or question D if they wanted a bit more of a challenge. Wow, you done, Sabahle. That's great. Nice. Well done. And Danelle, good job. And Chiamo. And Angelique, good. And Mihlali. All right. Good job, everybody. Okay. All right. So I'm seeing lots of dones here. So I'm just going to clear a little bit of space. And what I'm going to do this evening is normally I would ask for somebody to come forward and share their answer, but I'm not going to do that this evening because I really want us to get onto the next question. So just very, very quickly, I'm going to go through these and I hopefully am not going to lose anybody. Okay, so if you did question C, you should have said that the coordinates at the center are -4 and 1. The coordinates at the point of tangent C are -2 and 3. So remember, your radius is the line TC. So when we calculate the gradient of TC, we would have said 1 minus 3 over -4 plus 2. So when I write plus at the bottom, it's because it was minus minus. So that would have given us -2 over -2. So we end up with a gradient of 1. Okay, so this one would have been a little bit easier because the gradient of the radius times the gradient of the tangent would be equal to -1. So that would give us 1 times the gradient of your tangent is -1. So therefore the gradient of your tangent should also be -1. Subbing into y equals mx plus c, you would have y equals -1 x plus c, and then your coordinates at the point of tangent c, sub those in. So 3 equals -1 times -2 plus c. So c would be equal to -1 times -2 is 2, so that would be 1. Okay, so in C, did you have y equals x plus 1? Oh. Did I make a mistake, Yolanda?
Yes, ma'am.
Oh, did I, Lusanda? Where did I make a mistake?
Not +3. The points
On the,
the coordinates for T. It's not +3, it's -3.
yes,
Oh, sorry. Oh, man.
yes, it's
What
just
an
the
idiot.
negative part.
Sorry, guys. So there was a negative over there, beg your pardon. So that was
There we go.
-3. Sorry, so now that actually changes things, doesn't it? Because that's
Yeah,
going to become a plus.
yes.
Sorry, guys. Okay, so
No,
that
we
was
saw it
4 over
late.
negative, sorry, beg your pardon. So that's 4 over -2. So the gradient is actually -2 then, isn't it?
Yeah.
Absolutely. Okay, so then that should be -2, which means that this should be 1 over 2. It's just, sorry, guys. This is what happens if we make a mistake, hey, or we write something down incorrectly. Okay, so that would have been half x, and then we would have subbed in the coordinates at our point of tangency. So that's a half. X was equal to -2 plus c. So a half times -2 would be -1, plus 1 plus 1, that would be -2. Okay, so here, did you guys have half x minus 2? There we go. Good, well done. Well done, everybody. Good, 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 good. Okay, so that was fine. Right. Did anybody try question D? Yes. Oh, lovely. Wes. Yes, yes, yes. Good, good. Did anybody try question D? Yes, Angelique, okay, and a couple other people. So here you would have had to complete the square first. All right, so what I'm going to do is just rub this off. And let's just talk about what would happen with that one. Always good practice to complete the square a little bit. Okay, so with this particular question, when it came to completing the square, you would have ended up with x squared minus 2x, and then here you should have added 1 plus y squared plus 4y. So there you should have added 4. You should have taken 5 over to the other side, and because you added 1 to the left and 4 to the left, you must add them to the right-hand side as well. Sorry, I'm doing this quite quickly. This then gives us x minus 1 squared plus y plus 2 squared is equal to 5 plus 5, which is 10. That means the coordinates at the center are 1 and -2. The coordinates at the point of tangency are -2 and -1. So the gradient of TC would be -2 plus 1 over 1 plus 2, which gives us -1 over 3. So the gradient of TC times the gradient of our radius has to give us -1. So if this is -1 over 3, it means, sorry, that should be tangent. We should have had the gradient of our tangent was equal to +3. Okay, did you get that, guys? Okay, and then we would say y equals 3x plus c. I'm just subbing it straight in there. Subbing in the coordinates at the point of tangency was -1 times 3 times -2 plus c. So this would be -6 plus 6 plus 6, and that would give us 5. Did you get y equals 3x plus 5? Okay, so Mihlali, remember when you complete the square?
Okay, so Mihlali, remember when you complete the square?
Sorry, Asanta, can you just mute, please?
Sorry, Asanta, can you just mute?
Sorry, I muted all of you because some of you guys were unmuted.
Yeah, sorry, then I hear my own voice repeating and then I can't think properly. Okay, so when you complete the square, remember you have to take half of the coefficient of your x term. So that would be -1. Then you've got to take that and you've got to square it. And that's what you've got to add over here, because you add it to the left, you've got to add it to the right. Okay, and it's the same thing for the y term. You've got to complete the square for y and you've got to complete the square for x. Okay, so when you're completing the square for y, it's half of 4 is 2 and 2 squared is 4. You've got to add 4 to the left, so you've got to add 4 to the right. Okay. Okay, it's given to you, Lebogang. This is T over here, the point of tangency. Okay, that was given to you, the coordinates at the point of tangency. Good, lovely. Well done, everybody. Okay, so now let's jump into a more difficult question. All right, so actual application of what it is that we've learned. No problem, Lebogang. So in the diagram alongside, M is now the center of the circle, and they've given us the equation of the circle. X minus 2 squared plus y plus 5 squared equals 36. And they've told us that BC is a tangent to the circle at C. If B has the coordinates 8 and 3, calculate the length of BC. Okay, so completely different sort of question now. Now they're asking us to calculate the length of part of the tangent. All right. Let's just think about the information that we've got, and then we can see if we can put it together. We know the coordinates at the center of the circle, right? The coordinates at the center of the circle would be 2 and negative 5. That comes from here. The other thing that they have given us is r squared. Remember, if it's in center radius form, they've told you, if they've given you a value on this side of the equal sign, they've told you that r squared is equal to 36. So if they've told you that r squared is equal to 36, it means that r would be equal to 6. So you know the length of the radius. The radius is cm, and we know that it is 6. They've given us the coordinates at B. Good, CM Tanda. What do you think we're going to use now to calculate the length of BC? And I'm afraid that it is not distance formula. It's not distance formula. What do you think, Matrix? How are we going to calculate the length of BC? Excuse me. Anyone got any ideas? How would we calculate the length of BC? And it's not distance formula. In Nhlanhla, I can understand why you are saying that, okay? When we first look at this question, that's exactly what we think. We need the coordinates at C, because if we've got the coordinates at C, we can use distance formula and we can calculate the length of BC. In this particular example, there is not enough information to allow us to calculate the coordinates at C. Okay, because we do not have the equation of the tangent. So the equation of the tangent is missing, and the coordinates at the point of tangent C are missing. Because those two pieces of information are missing, we cannot use the coordinates at C, or cannot get the coordinates at C. So we've got to think of something else. Anyone got it? There we go, Gugu. Well done. So I don't know if you can see what Gugu has said in the chat, everybody. Can't we construct a triangle and use Pythagoras, ma'am? Well done, Gugu. Perfect. Okay, so you are allowed to do this in analytical geometry in matric, all right? CM doesn't exist, but just because, no, it's not that it doesn't exist, it's not drawn, should I say. So we are allowed to draw it because it's a radius, it's perpendicular to the tangent. The other line that is not drawn is line BM. Okay, but we are allowed to draw it. This makes a right-angled triangle. And we can use the theorem of Pythagoras to calculate the length of BC. Isn't that clever? Right, so before we can use the theorem of Pythagoras, we need to know the length of BM. So for that, we can use distance formula. So we're going to use distance formula to calculate the length of BM. So I'm going to sub in there quickly. So our change in x's squared plus our changes in y squared. And that means that the length of BM is, just double check me here, matrix, 2 minus 8 squared plus minus 5 minus 3 squared. and that gives us 10. Okay, so we've got the length of BM. All right, now that we've got the length of BM, we can say that BC squared plus CM squared equals BM squared. Okay, thanks to good old Pythagoras. Okay, so you must not forget about the theorem of Pythagoras. So the minute you see the word length, it's not always distance formula. Okay, Pythagoras can help us as well. So BC squared is what we want. We know that the radius is 6. We've just calculated BM to be 10. So BC squared will be equal to 100 minus 36, which gives us 64. And remember, we're only working with positive numbers here because we're talking about the lengths of sides of a triangle. So if BC squared is 64, it means that BC is equal to 8. Okay, isn't that clever? Yes, Leanne, perfect. Indeed it is. All right, so not that difficult, but somebody needs to point this out to us. Okay, so just very quickly again, with the information that's been given, we've got the coordinates at the center and we've got the length of the radius. Remember, if they give you the equation in center radius form, you know the length of the radius. Because we have the length of the radius, we do not have the equation of the tangent. We also do not have the coordinates at the point of tangency. So we don't have enough information to calculate the coordinates at C. That means we've got to use the theorem of Pythagoras. We can make a right-angled triangle by connecting the center, M, to C and M to B. Okay. Okay. Yes, I used a root, Palesa, quite right, the square root. Okay. All right, you guys ready to try one? Any questions?
We are ready.
Are we ready? Okay.
Looks like we're ready.
Are we ready? All right, we're going to go for it. Okay, so here we go. I wonder if I could move that up a little bit. Okay, so a circle with center M is given. BE and EL are tangents to the circle at D and N respectively. That's the equation of the circle. The equation of the tangent BE is y equals half x plus c. All right, so the first thing that they want us to do is calculate the coordinates at the center, determine the center M. So they want the coordinates at the center and the radius. Okay, so you guys are going to do that. Then we're putting all of this together now. Determine the equation of the radius MD and hence show us that the coordinates of D are 3 and 4. And now finally, if the coordinates of L are 9 and 0, calculate the length of LN. All right, so I'm going to let you guys try this question. Please try and do A, B, and C. And when you're done, you can say done in the chat. Okay, let's give it a go. Just try and see how we can fit all of this information in. Okay, so Bohlali, what I'm trying to do is just make sure that it's all on the screen. There we go. Okay, there you go, Bohlali, and everybody else, you can take a screenshot. Okay, so Snotile. All right. Everybody else, you carry on working. The coordinates at the center M. Okay, so you have been given this equation in general form. Okay, so you need to do something with general form to get it into center radius form. Okay, and we've just had a look at an example of that with what I've just done. Okay, so I'm just going to leave a little hint for you. You have to complete the square, okay, to get the coordinates at the center M and the radius. Oh, you're referring to the previous question. Okay, so hang on, there we go. Just quickly take a screenshot. So I've got to go back down again. So BC was equal to 8. Okay, Bohale. Okay, I'm going back down, Bohale. I hope you're done. Okay. Cool. Lovely. Oh, sorry. You guys keep working. I'm just slowly starting to put the answers up behind you, but I'm sure you're all done with part A already.
No, this one is for you, Snotile. Hopefully you got
That's it,
this one.
Leanne. Me too. Yes. Snotile, I hope you got this too. Sorry, guys. I'm just ever mindful of the time. It just goes by way too quickly.
Teacher Lee, I think we wrote -2 instead of on the gradient. Sorry, on the M, on the center. It's 4 and 2.
Oh, hang on. Sorry. So it should be 4 and 2.
Yes.
Yeah, sorry. There. That's it. Yeah. +4, +2. Good. Well done, guys. Good.
Well done, my people.
Well done, everybody. Nice, Yamtanda. Nice, Palesa. Good. Well done, Pondora. And Mihlali. Good. Good. All right. There's a whole bunch of you that got that. Excellent. Excellent. Have you guys done part B? And Linda, and Carol, and Lebogang. Well done. Okay, so Lolita's finished with part B. Orotila's done with part B. Angelique's done with part B. So's Palesa, so's Danelle. Okay, so I'm just going to slowly start working on B. If you're on C, you just continue. Good, everyone. Good, nice, lovely. So you guys have all got the equation of the radius MD. You've got the same answer as me. Okay, but the hence part, yes, Sinclair, I agree. So that was what I was going to talk about now, okay? Normally in exam sorts of questions, it could be hence show that the coordinates of D. All right, so it means that we need to use the equation of the radius in order to be able to get it. Now, the problem, and I use the word problem in inverted commas here, is that we need to solve for D simultaneously. The other thing I want to point out to you here, Matrix, is that D is a point of intersection of three things, not just two: the tangent, the circle, and the radius. So you can solve simultaneously between any two of those three. So either you could solve simultaneously between the radius and the tangent, or the radius and the circle, or the circle and the tangent. The problem is with the tangent is that they haven't given us the y-intercept. That would have been quicker and easier if they had, but they were being a little bit mean to us. All right. So in order to do this part, we need to solve simultaneously. So in other words, what we've got to do is we've got to take this equation over here and solve it simultaneously with our circle. Okay, so don't forget about simultaneous solutions. Okay, so where I would have x minus 4 squared plus in place of my y. Yes, Teddy, you got a question? Go for it, Teddy.
Ma'am, I just want to know,
Yes,
why did
sure.
you sub the center points into our equation? Is it because that point lies on the line of the
Yes,
radius?
yes, that's right. So DM goes through the center of the circle because it's a radius. Okay, so I can't use the coordinates of D. Yeah, I can't use the coordinates at D, because when they say to me, hence show that the coordinates of D are this, I can't then go forward into the question and take something and then go and substitute that in, especially when it says to me, please show. All right, so show means you've got to prove it. Okay, so you're not allowed to use it by substitution. Okay. Yes, Nautila's solving simultaneously is definitely one of the more difficult things that they expect us to do. Okay, Zinhle, what was your question?
Ma'am, I'm confused here. You only wrote for the circle coordinates, you only wrote the coordinates of x, but you're not using the coordinates of y.
Yes, because I substituted. So what I've done over here, can you see I have replaced y with minus 2x plus 10? Because remember, that's what I'm subbing in.
Oh, okay, I get it.
Okay, so this is now me solving simultaneously. So what I've done is I've taken that and I've gone and subbed it in over here. Okay, I'm just going to tidy it up a little bit so that it's going to be nice for me to work with. All right, so I've got x minus 4 squared plus, and then inside here, I've got minus 2x plus 8 squared is equal to 5. So squaring my binomial, I'd end up with x squared minus 8x plus 16, plus this would be 4x squared. Multiply the two together and then double it. So that would be negative 16, that would be negative 32x. Square the last term, which would be 64. Bring the 5 over from the other side and make it equal to 0. Okay, so you've got to solve simultaneously between the radius and the circle for this question. Okay, so now let's collect together our like terms. We've got 5x squared. Remember, we've got to be super careful here. Then it looks like we've got minus 40x. And then we've got what? 16 plus 64 minus 5, which gives us 75 is equal to 0. Divide through by 5. and we'd end up with that trinomial. Now we can factorize, or if you wanted to at this point over here, you can use the quadratic formula. Remember, you've got to show when you've subbed into the quadratic formula. So we would end up with x minus 5 times x minus 3, and therefore x would be equal to 5, or x would be equal to 3. So we're going to choose the 3. Okay, because that's what D is. So at D, X is 3. So at D, X equals 3. And then that means we can go back and sub into the other linear equation, this one over here. So we'd say Y equals, whoopsie, negative 2 times 3 plus 10. And then Y would be equal to 4. So therefore the coordinates of D are 3 and 4. Okay, so that was a simultaneous. Can you see now why we spent lots of time earlier in the course talking about simultaneous solutions? You can see now why we need to be able to do that. It's in many different. Why did we divide by 5? CM Tunda, just to make my factorizing easier. Okay, because then the coefficient of my x squared term is 1, just makes factorizing easier. Any other questions? Yeah. Okay, and then the last bit, I don't know if you guys got as far as question L. Sure. So take a screenshot of A and B quickly if you need to do so. This is also part of B over here, essentially. Wow, Oratile, good question. So any simultaneous solution is probably going to be out of about 5. Finding the equation of, so here there would be a mark for completing the square, accuracy marks there, accuracy sub in answer. So that would probably be out of 3. That would be out of 3. This would probably be out of 5. Okay, so subbing in standard form factors. Mind you, you wouldn't get a mark for this because that's given, probably a mark there. So yeah, maybe 4 for that second bit. Okay, and then the last one, if you calculated the length of Ln, just very quickly, because we've only got 4 minutes to go. So Bartley, how did you get 16 and 4? Yeah, we're rejecting the 5, Leanne. 16 and the 4 from completing the square. Okay, so for those of you that managed to do the length of Ln, you should have calculated that Ln was equal to root 24. That was the answer for Ln. Right, what you needed to do here as well was create a right angle triangle. You know the length of MN. Remember, you worked out the length of the radius in the first question. That was root 5. You know the coordinates at M from the first question as well. That's 4 and 2. You know the coordinates at L. It's 9 and 0. So similarly to the last question that I've just done, the last example, you would use distance formula to calculate, the length of LM. So that would be 4 minus 9 squared plus 2 minus 0 squared. That gives you root 29. So sorry, this is part C now.
Tali, can I go to the other class? Is it fine?
Yes. Go to the other class. I'll just finish up with them and I'll be right there. Okay.
Perfect.
And then you would have done Pythagoras again. Okay, matrix. So you would have said mn squared plus nl squared gives you ml squared. So mn squared is 5 squared plus nl squared equals root 29 squared. So nl is 29 minus 5, and that's where your root nl equals root 24 comes from. So take a screenshot of that as well. Okay, so will you see where I've just showed you that here in red? Okay, you've got to draw a right angle triangle by connecting M to L. Remember, your radius is always perpendicular to your tangent. Okay, so this question kind of brought everything together that we've done.